There are many ways thermal imaging can help you conduct planned maintenance. We're going to take a closer look at some of the most common ways.
Thermal images are powerful aids for identifying power quality related problems in three-phase electrical panels. Even a small temperature difference between phases might indicate an unbalanced or overloaded system, bad wiring, loose connections, or problems with harmonics. Such power quality related problems could soon lead to a motor overheating and eventually breaking down, or an electrical short circuit bringing the risk of fire. When checking for power quality related problems, ensure you capture thermal images of all electrical panels and other high-load connection points such as drives, disconnects, and controls. Check panels and other connections with the covers off, using proper safety protection and practices. By capturing a thermal image of all three phases side by side, you can quickly spot temperature differences between the individual phases. Even a small difference of a few degrees Celsius should be further investigated. If the temperature difference between the phases is above 15 degrees Celsius, immediate action must be taken. Let's have a closer look. Here you can see a thermal image of a three-phase system. The temperature of phase 2 clearly shows about a 21 degrees higher temperature than the other phases. This is a clear indication that something is wrong. The temperature distribution over the cable suggests a bad connection, although an unbalanced load, overload, and harmonics can all result in a similar temperature pattern. To understand what actually causes this temperature increase, additional measurements need to be done. The loading on each phase is easily checked with a current clamp. For more detailed analysis of three-phase power problems, a power quality analyzer is the ideal tool. Hooking up a power quality analyzer will clearly show any unbalance in the system.
Another area where thermography is a maintenance professional's best friend is electric motors.
A recent estimate of the number of electrical motors used in industry around the world is over 40 million. And these motors use 70% of all the electricity consumed by industry. So keeping your motors running in top condition is extremely important. When checking electric motors, do so under normal operating conditions. Unlike an infrared thermometer that only captures temperatures at a single point, a thermal imager captures temperatures at thousands of points in real time. A single image includes all critical components, such as the motor, shaft coupling, motor and shaft bearings, and the gearbox. All motors should list the normal operating temperature on the nameplate. Even though a thermal imager cannot see the inside of the motor, the outside temperature is a good indicator of what's happening inside. If a motor runs at a temperature 10 degrees Celsius higher than specified, its life cycle is halved. This increases both maintenance costs and the risk of expensive downtime. A motor running at higher temperature than specified may be due to bad cooling, power quality related problems like harmonics or unbalance, or insulation problems with the motor windings. Mechanical problems such as bad alignment or broken ball bearings could also cause a motor to overheat. A thermal imager quickly checks the operating condition and finds possible hotspots. Problem solving may be as easy as cleaning the air intake grills. For more complex problems, especially those related to the power, it's advisable to use additional measurement tools like a current clamp. The condition of the motor windings is easily checked with an insulation tester. Insulation failures should be repaired as soon as possible. An overheated bearing is easily seen using a thermal imager. Misalignment or bad lubrication might be the cause for this bearing overheating, meaning it is likely to fail if the problem is not rectified.